Okay guys, about the shear force and bending moment, you have learned them out in your mechanic course. Just for review before you start for shear force and bending moment for vessels. Just remember, shear force is under curve area of load force. Whatever is your load pattern on the lever on your object, shear force is the under curve area for the load force, and bending moment is under curve area of the shear force. So what that means, in this graph, assume this is your lever from point O to point X. Oh, this is your lever from point O to point X, and I assume 2 points is point A and B. We want to calculate shear force and bending moments at point A and point B. What is the area from point O to point A? This is your load pattern. Could be weight of the your object, could be some additional weight on that one, or some pushing force, which for the vessel could be buoyancy and weight of the vessel and object you have in the vessel, load cargo. So this is the final load curve as a net. What is the positive load and what is the negative load? This green one is a final load on your object. So from point O to point A, what is the under curve area? That's I marked as number 1. From point A to point B, as you've seen, our curve is crossing 0 because our load will be negative. That means our load is in either direction. So you have to consider about the positive and negative area. So you have to divide it in 2 parts anytime you're crossing 0 line. So this is area number 2 and area number 3 between A and B. So then between A and B, we have to divide the area to 2 parts because your load curve has crossed 0 line. Okay, so from point O to point A, you have one area. From point O to point B, and again remember, while you want to calculate point B, shear force on point B, you have to consider all the load force from point 0, point O to that point, not just from your previous imaginary points. Well, if you want to draw the shear force on that one, just what is in the point A, it's in this point which you are going to graph. This is under curve area of load force. How much was your load force at here? The area is number 1. In your shear force drawing, just as you see number 1 here, so you are going to mark it, and from point O, you're going to draw it to point A. So this is the shear force in point A, that is this much. For point B, if you go back to your load curve, you have area 1 is positive, area 2 is positive, but area 3 is below the 0 line, so it's negative. To calculate shear force in the point B, you have to calculate area number 1, area number 2, and add these 2 together and minus area number 3, because area number 3 is negative. Okay, so this is in the shear force in point B, area number 1 plus area number 2 minus area number 3. Okay. And also notice, anytime your graph is meeting 0, touching 0, under curve area, you have a peak, either maximum or minimum. And as you see in the load force, this point and this point, you have crossed zero. Thus, in the shear force, which is under curve area, you have a maximum or minimum, a peak, could be either of them, in your shear force. So if you want to draw the bending moment diagram, bending moment is under curve area of shear force. So we have our shear force drawing. We want to calculate bending moment at point A. You are going to calculate under curve area for shear force from point O to A, which was I highlighted here as number 4, area 4. The area between A and B I highlighted as area 5. For shear force at the point A is whatever was under curve area of shear force is bending moment, and for point B, the under curve area for point B is summarize of whatever was from point O to here, 4 plus 5. Okay, and this is the bending moment. While our shear force does not cross zero, we don't have a peak, maximum, or minimum, so our bending moment in this drawing, all of them are positive.